Our nation depends upon accurate and timely environmental data to safeguard our civil, economic, and military interests against the uncertainties of weather. NPOESS, the National Polar Orbiting Operational Environmental Satellite System, will play a pivotal role in national weather preparedness for the next 20 years. NPOESS satellites will circle the globe in low Earth orbit approximately once every 100 minutes, providing global coverage and monitoring environmental conditions, collecting and disseminating the Earth's atmosphere, oceans, land, and near-space environment. The data obtained by the NPOESS constellation will help to reduce the potential loss of human life and property by enabling more efficient disaster planning and response to extreme weather conditions, such as hurricanes and floods. Civilians will benefit from the satellite's data in the areas of civil aviation, agriculture, and maritime activities. Military users benefit from NPOESS as well, shifting their tactical and strategic weather focus from coping with or avoiding weather to exploiting and anticipating atmospheric and space environmental conditions. The NPOESS system will collect very precise Earth surface, atmospheric, and space environmental measurements from a variety of onboard sensors. This highly precise data will allow scientists and forecasters to monitor and predict weather patterns with greater speed and accuracy than ever before. The NPOESS Integrated Program Office, or IPO, represents an historic coalition of the civil, scientific, and military weather communities, which have come together to shape a single, more affordable system to replace the current separate military and civil systems used today. Northrop Grumman is working with our team members and the IPO to create a system that will provide accurate and timely data to users worldwide. As prime contractor, Northrop Grumman is responsible for overall system design and development, including acquisition of sensors and assembly and test of the spacecraft. Our team member Raytheon will provide the ground systems, including the data processing segment, the communications command and control segment, and the field terminal segment software. Ball Aerospace and Technologies, Boeing, ITT Industries, Northrop Grumman Electronic Systems, and Raytheon Santa Barbara Remote Sensing are responsible for design and development of the 4 key NPOESS instruments. 9 other instruments or payloads round out the complete set of NPOESS sensors. Ball is developing OMPS, the Ozone Mapping and Profiler Suite, a sensor that will collect vital ozone information. OMPS data will be used to help determine if synthetic chemicals are affecting the Earth's climate and fulfill international treaty obligations to monitor ozone depletion. At ITT Industries, engineers are working on the first operational use of an interferometer in space as part of the cross-track infrared sounder, CRISS. CRISS has already completed initial performance testing and vibration trials to be certain it can construct vertical profiles of atmospheric temperature, moisture, and pressure to make weather forecasts more accurate. Northrop Grumman Electronic Systems is currently at work on the Advanced Technology Microwave Sounder, ATMS. ATMS will, in conjunction with CRISS, provide global observations of atmospheric temperature and moisture profiles at high spectral and temporal resolution, a must for accurate and timely weather forecasts. VIIRS is being developed and tested at Raytheon's Santa Barbara Remote Sensing facilities. Here, the laboratory prototypes of flight subsystems have demonstrated the integrated sensor system capabilities. In operation, VIIRS will provide high spectral and spatial resolution imagery for the next generation improvement of global data products, including hurricane tracking forecasts, fire detection, atmospheric aerosol measurements, sea surface temperature mapping, ocean color observations, vegetation index mapping, and surface ice and snow mappings. Together, our team members represent decades of experience in providing solutions to challenges with great national significance. For weather data to be useful, it must be accurate and timely. Latency, the time between when weather activity is observed and when it is delivered to users, must be short enough so that appropriate warnings can be made, or so that authorities can implement proper emergency or other measures. Military users depend on near real-time data to enable units to exploit favorable weather conditions rapidly or to avoid unfavorable ones that could hamper maneuverability. Our team's NPOESS data delivery system cuts latency by a factor of 4 over current systems, reducing observation to delivery time to just 15 minutes for 75% of NPOESS's collected data products. We achieved this stunning improvement through a Northrop Grumman-designed innovative data delivery system called SafetyNet. The SafetyNet system is a globally distributed grid of 15 low-cost unmanned ground receptors tied into existing commercial fiber optic networks. The SafetyNet system coverage is nearly contiguous as the orbiting spacecraft travel from the field of view of one receptor to the next, greatly reducing onboard data storage times. With the SafetyNet system, 95% of NPOESS data is delivered to the 4 U.S.-based environmental data processing centrals, the main data processing facilities for weather data, within 28 minutes, much faster than the currently operating systems. After download, mission data is sorted and formatted into sensor spacecraft packets before being moved into the Data Interface Processing Segment, or IDPS. The sheer volume of data produced by the 3 NPOESS platforms would hobble most data processing architectures. Our team's environmental observing system, data processing experience, led us to design a flexible parallel processing approach that breaks up incoming data into manageable portions that can be rapidly parallel processed. Designed for speed and flexibility, this multi-processor switched fabric connectivity system is ideal for the NPOESS IDPS. The system's multiple processors quickly sort the incoming data stream into records that are tailored to specific users' requirements or are merged to generate fusion products for use by multiple agencies. To ensure 100% data integrity, the IDPS Workflow Manager autonomously reassigns processing tasks if processor faults occur. Development of the Interface Data Processing Segment, or IDPS at Raytheon, is progressing well, representing the powerful heart of the NPOESS ground data processing system. NPOESS end users range from military units operating from fixed and remote terminals to scientific and educational institutions, each with their own unique data handling capabilities and requirements. As a result, NPOESS's full data set is broadcast to Earth, both in high-frequency X-band as well as a subset transmitted at a lower data rate in L-band, ensuring that respective users receive the data in a form that is accommodated at their sites. Operators manage NPOESS space and ground assets using a complex suite of command and control mission management software at the NPOESS Mission Management Center, MMC. The software development for MMC is complete, and final factory acceptance testing is being conducted prior to delivery to the new NOAA Satellite Operations Facility in Suitland, Maryland. The NPOESS Preparatory Project, NPP, is a joint NASA-IPO System Risk Reduction Project. NPP's mission is to demonstrate advanced technologies for atmospheric sounding and imaging, giving continuing observations about global change after our current Earth-observing system missions are completed. The NPP spacecraft is being built at Ball Aerospace. Our NPOESS team is building on a legacy of successful Earth science satellites, using a fully functional high-fidelity simulation facility and employing decades of spacecraft integration experience to deploy a constellation of NPOESS satellites that will help to take weather and environmental science to the next level. Supporting NOAA's long-term environmental monitoring mission, NPOESS will provide data essential to understanding the forces that shape the world's climate, including global climate change. Our team is proud to be a partner in helping the Department of Defense, NOAA, NASA, and the extended user community to develop an environmental space system to ensure the safety of civilians and our men and women in the armed forces.